Hello everyone, in this video we will be solving an example on topic frequency domain sampling and reconstruction of discrete time signals. In the given question, a sample signal x of n equal to a power nu of n, where a is ranging between 0 and 1. In the question we have to find out the reconstructed spectra for a equals 0.8 when n equals 5 and n equals 50. Now, let's see the solution. First we need to find the Fourier transform of the given sample, then we will get x of omega. Since a is less than 1, we get 1 by 1 minute a power minus j omega by n equidistant frequencies. Now, we sample x of omega. Now we replace omega k with 2 pi k by n. Now by IDFT we need to reconstruct the original sample, where the factor 1 by 1 minute a power n represents the effect of aliasing. Since 0 less than or less than 1, the aliasing error tends towards 0 as n tends infinity. For r equals 0.8, the sequence xn and its spectrum x of omega are shown in Fig. 7.1.4a and 7.1.4b respectively. The aliased sequences xp of n, for n equals 5 and n equals 50 and the corresponding spectral samples are shown in Fig. 1.4c and 7.1.4d respectively. We note that the aliasing effects are negligible for n equals 50. If we define the aliased finite duration sequence xn as x cap of n equals to xp of n, where 0 less than or equal to n less than or equal to capital N minus 1 otherwise equal to 0, then its Fourier transform. Now the DFT. The development in the preceding section is concerned with the frequency domain sampling of an aperiodic finite energy sequence x of n. In general, the equally spaced frequency samples x of 2 pi k by n, where k equals 0, 1, so on till n1 do not uniquely represent the original sequence x of n when x of n has infinite duration. Instead, the frequency samples 2 pi k by n where k equals 0, 1, so on till n1, correspond to a periodic sequence xp of n by period n where xp of n is an annualized version of xp of n. In reconstruction of 3 from 4 figure, we see that our reconstructed signal is not very close to original x of n, and it is because of aliasing. We saw the expression like a power n by 1 minute a power n. Here n equals 5, so our samples are not purely resemblance. For n equals 50, our sequence is nearly equal in magnitude to given sequence. So as the number of samples increases, we get close to our original sequence. Edit box, content.